So this is the last section or last part of 12.2, solving right triangles. So in the first two, we just had triangles and we solved them. There are many applications with trigonometry, and it's very helpful in several different fields. And here we'll just look at one of them. So we have a couple new terms here, which kind of makes sense just in our everyday language anyway, but we have the angle of elevation and the angle of depression. So I know this is small, but you have a little figure here to the right also. The angle of elevation, so let's start with this. Angle of elevation is the angle formed by a horizontal line and the line of sight toward an object that is above the horizontal. So looking upward. So angle of elevation is this angle up here. So if this fella here is looking at a bird, there's an angle of elevation. If he's looking down at a tortoise, tortoise with an extra leg, angle of depression. All right, so that's what those two angles refer to. So it's compared to the horizontal, and then the line of sight either above the horizontal is elevation, below the horizontal is angle of depression. All right, so here we have a survey team flying at an altitude of 7,000 feet, measures a 7.5 degree angle of depression. So they're looking downward to the summit of Mount Mitchell. After flying another 2,400 feet, they are directly above the summit. How high is Mount Mitchell? All right, so they are flying at an altitude of 7,000 feet. So in this case, the figure is given to you. Sometimes you might have to sketch it out on your own, but here we have it drawn out for us. So you see they were started 24,000 feet away. They're 7,000 feet in the air, and they had this angle of depression that is 7.5. Well, right now we're going to look at this triangle I'm going to outline here in red. So they're above the mountain, which is good. We don't want them to crash into it. So we want to find this value x, and if you think about it, we can figure out how high the mountain is once we get x by taking 7,000 and subtracting x. So let's get to it. We notice, so thinking through our steps, we have an angle and a side. That was the first situation when we had an angle and a side. So we look at the angle that we know is the 7.5 degrees. The side that we know compared to that angle is the adjacent leg. And the side that we want to find is the opposite leg. So we have been bumping into tangent here quite a bit, but realize sine and cosine are often used as well. So I already gave away the next part. We have adjacent and opposite legs, so we know that we are going to use tangent. And so we write our equation. Tangent of the angle we're referring to, which is a 7.5 degree angle, is equal to the opposite leg, which is the x, over the adjacent leg, which is the 2,400. Tangent of 7.5. Now, if you're getting better at your calculator, to solve for x, really, we just know we have to multiply both sides by 2,400. And you can put this right in your calculator as is. So I'm going to show you how you can do this. It's the quickest way to do it. You just have to be careful. It does help to start with the 2,400. Less mistakes are made. And I can show you where mistakes are made sometimes, but we have 2,400 times tangent of 7.5. And so x is 316 feet. Now, the mistake that's made sometimes on this is people will do tangent of 7.5 times 2,400. And so I'm going to type it in the calculator here, and this is what they might type. So tangent of 7.5, and instead of closing the parentheses, they forget to close the parentheses and just type in times 2,400, and that is going to give the incorrect answer because it's multiplying 7.5 times the 2,400 first and then taking the tangent. So you get 0. So you want to make sure you do tangent of 7.5, close the parentheses, times 2,400. And there you get the correct answer. So that's the value of x. Remember, we are not finished yet. We want to find out how high is Mount Mitchell. So we're going to take the 7,000, because they were flying at 7,000 feet, subtract 316, and you get 6,684 feet. And that is the height of Mount Mitchell. And then moving down to this last one, a surveyor must find the distance between two posts, A and B, on opposite sides of a river. After placing a post directly across the river from B at C, she walks downstream along the bank, perpendicular to the line formed by B and C, and measures AC to be 180 meters and measure of angle A to be 43 degrees. Find AB. So this isn't going to be a wonderful sketch, but here's our river. It's blue, nice clean river, and we have a couple posts here on the river. It says A and B are on opposite sides of the river. So let's say here's A, and B is somewhere else. So here's B. All right. After placing a post directly across the river from B at C, so she places something right across from it, B, and that's point C. She walks downstream, perpendicular to BC, so perpendicular to BC. She walks to A, and she finds that AC is 180 meters, and angle A, well, to get angle A, we have to finish this up here. Angle A is 43 degrees. And what do we want to find here? Find the length AB across the river. So obviously it would be hard to find that length if there's a river there to try to put a tape measure across there or whatever it might be. So they're going to use some trigonometry. So we see we have a triangle here. We're trying to find the length of AB. Let's call it X. And so let's look at this. We have an angle and a side. So we have an angle and a side. That means we want to, so our angle is 43 degrees. The side that we know is adjacent to that. So we know the adjacent side, and we know the hypotenuse. So we know adjacent, we want to find hypotenuse, and so what deals with adjacent and hypotenuse? Well, there it is, A and H, so we're using cosine. And so now we want to write our equation. Cosine of the angle we're referring to, which is 43, equals the adjacent over the hypotenuse, which is X. So when we have X here in the denominator, we want to make sure we multiply both sides by X. And so that gives us X times the cosine of 43 equals 180. While we're at it, you can save a little time here. I showed you before you can type this whole thing in the calculator at once. Well, we can do something similar here. We're going to divide both sides by the cosine of 43. I didn't find what it was. I'm just going to write cosine of 43, and then on the calculator we can do this. So we're going to do this expression right here, 180 divided by the cosine of 43. Close the parentheses, hit enter, and X is 246, and this is in feet. So about 246 feet. And so there's